We're going to talk you through getting into MATLAB for the Calculus 3 course at Southern New Hampshire University. Start with, under the course menu, learning modules. The information you're going to need is in Module 1 to get us started. And we scroll down, we've got the practice assignment and creating the MathWorks account. So under creating your account, if you've never used MATLAB before, for another course here, you'll click on the MATLAB access instructions. Now I'm not going to click on the portal here because I've already made an account, and if you go through that after you've already made an account, sometimes it gets a little fussy. But you'll click on this, it will bring up this information. You'll use your SNHU credentials, get all that stuff created, and it will have set up your MathWorks account. Once you've got that going forward, this matlab.mathworks.com link, that's the one that you want to be using for everything. So I'll click on that right now and open MATLAB online. Once we get in there, everything's loaded up. It should be loading for you. This first steps in MATLAB offers you some basic instructions, a few different things you can practice, and a video for some more detailed exercises. This isn't a required thing to submit, but you are encouraged to go through this, right? It's worth taking your time. But everything that we're going to do in here, we're going to go back to our Brightspace course. Every one of these sections, every module will have a MATLAB either practice assignment or in weeks 4 and 7 a MATLAB project. You're always going to start by downloading a template. Even here, the project, it's not due until Module 4, but the guidelines and the rubric are already available to you, so you can start on those early. But let's start with this Module 1 template. Click on that to download it. I've downloaded it a bunch of times, so it's showing up with some different numbers. But once I've got that, you should be able to drag it over here, and it's going to load it up into your MATLAB file. I have found that in some browsers, it does not work for you to just drag it over and drop it. If that is the case for you, you will want to reach out to the SNHU help desk and let them know that that's a problem for you. If this does not work, you should be trying this the very first week of class. If this does not work, you must let me know, and you must let the help desk know so they can get this figured out for you. But once we've got that, we've got the file in here, we're going to double click it. Now, each one of these templates will have an introduction and a bunch of examples. Most of what you're going to need to do for these practice assignments is copy the examples and modify them so that they answer the questions that you've been asked. Once you have everything ready to submit, you want to get rid of the examples, you want to get rid of the introduction. The actual submission should only be your work. That's all we need. So as we've got this going, here's our first example. Anything with the % sign in front of it is a comment. That's not going to be read by the program. It's there to tell the person looking at your work what this is supposed to be doing. So that's what we want to be setting up for these things. All of this code is a lot of copying and pasting. There's not a lot of new stuff until you get to the projects. The main thing we want to be practicing in here is that the code runs and that we've explained why this is the right code to answer the problems you were asked. So we can scroll through these different examples, see what's happening, see some places where it's generated some output, and then we come down to the problems. So use MATLAB to define these vectors, use the quiver3 function to plot them, set an appropriate view, label, and title, compute the dot product, compute the cross product. Let's go back up to the templates. Let's start by defining the vectors and use quiver3 to plot. So if I look back up at example 1, here's a definition of a vector, here's a definition of a vector, here's the quiver function that's being used to plot them, here's a way of putting labels and titles, just like I was asked. You want to do a 3D plot, here is the quiver3 command. So I'm going to go ahead and start here. And I'm just going to copy all the way down until I get to the end of quiver 3. Copy that, bring it down to problem 1. Now, this is way too much stuff, right? There's lots of things in here that aren't actually used to answer the question, and these vectors are different from the vectors in here. But I've still got all this in here, so I should be able to go up to this green button, click Run, and see if I can produce a little bit of output. So it's going to think about it for a while. You'll see here it still says pause. That means it's not done running yet. Now that it's back to green, it's run, and here's the output. So this is definitely not the output that you want, because this is just copied from the template, but it's your job to figure out how to modify this so that it answers the question that you were asked, where you've defined these vectors, use the quiver 3 function to plot everything, and then compute the dot product and the cross product. 2 ways that you need to explain your work. Explanations are at minimum 20% of your grade on every assignment. So this has to be done. This is what I'm really looking for. The code, here's Copilot. It will tell you what to do. I don't care about that. I want to know that you can explain to me why you wrote that code and what it's going to do. So the comments that go inside tell me what's going on, but also outside. And you will see in some later problems, it will actually say explanation here. And it will ask you to put in that explanation. So you can tell me what this is supposed to be doing and how you know it's right. You can put equations in here too. So if we go up to the top and we've got insert, equation, all these different things you can put up in here. Let's say we need a definite integral, and we're going to go from 0 to x of the function y squared minus 2z, y squared minus 2z dt, something like that. For these explanations, it will frequently help for you to put these things in here. Comes right out of the equation. Some students like to handwrite their explanations, scan those very legibly, high contrast, and then you can insert the image. That would be fine. When you've finished answering all of the problems and thoroughly explained your work and run it, making sure you do get valid outputs, the pictures are showing up. Once all that's done, you'll go up above the problem section and we will delete all of the examples. So now it's just your work. You put your name and date at the top. And when all that's said and done, you've got it ready. It answers every question you were asked. We go up here under Live Editor and then Save. So now it's going to keep this saved. All your projects for the semester will end up over here so that you can refer back to them. Export to PDF. It's going to make a PDF version, which has all of your code and all of your pictures right in there. It blocked my pop-up window, but now I've got it open. Now I can download the PDF of all of my MATLAB work and all of my MATLAB images and whatever else needs to be in there and all my explanations. Your final submission is turned into a PDF, downloaded, and that's what, when we come back into Brightspace, we've got our submission. So there's our practice assignment. We click on that, and the submissions are going to go in through there. So you submit that in the usual way as you would submit any assignment in there. There's guidelines and a rubric for all of these. Appropriate computations. Do the calculations you've written in your code work and answer the questions? Appropriate visualizations. If I ask you for pictures, do you have those pictures in there? Is it easy to see what's in those pictures? You've picked good contrasting colors, you've labeled all of your axes, that's what I'm looking for. And this is the part that every time I teach this class, lots and lots of students miss at the beginning. Appropriate explanations for the computation. I am looking for two things with that. Why does this code answer the question you were asked? And how do you know that this code is answering it correctly? So I should be able to tell. You want to think about this not just for me as the instructor, but if it was being written for another student in the class. Would that other student understand why you've chosen this code and what it's supposed to do, what each line of the code does, how you know the answer is right? So that's what we're looking for. This is stuff that you need to get started with absolutely in week 1. If there are any problems with accessing MATLAB, if there's any problems with dragging your file, if you can't get the PDF to export, you let me know so that I'm aware of your problem and you contact the help desk. So reach out if there's any questions. But the biggest issue that I usually see with students in this is that they don't start early enough. And then when they have technical problems, that gets in the way of the on-time submissions and can negatively affect the grades. So let's make sure we all get that started bright and early. And I will look forward to your submissions at the end of the first week.